Hello and welcome to the video. In this video, we are going to be making voltaic blades. You can see right here a quick preview of what we are going to be making. The first step in the process is to cut the blades out of the bar stock. Here you can see the stock I'm going to be using. It is S35VN steel, and you can see roughly where I marked the lines out for the cutting. There are a few different options I could use to cut this material, like a chop saw or an angle grinder, but I ultimately ended up going with a bandsaw because it's safer and cleaner. Before I can start machining the blades, I have to clean out my chip tray from my mill. I just finished machining all the voltaic handles, which are titanium, and my chip tray is completely full. You can see here that when I open up the tray, it starts to scrape the chip off and dump them on the floor behind it, which is something I want to avoid, and I did overfill this, and so I'm going to have to deal with that. I start by carefully opening it and vacuuming the chips off the top that I'm worried will fall off. You can see here that didn't really work and it ended up dumping a bunch of chips on the floor anyways. I'm going to finish cleaning up this mess. Enjoy the time lapse. Now that the chip tray has been cleaned out, it is time to tear down the mill and install the vise. You can see here that my vise has been rusting. I figured out I've been using my coolant at way too low of a solution, and so I went ahead and topped that up, and I'm still working on cleaning everything up that had rusted from that, but it's now fixed and nothing else has been rusting. You can see here I just started the process of tramming in my vise, which is the process of getting the vise perfectly square to the x-axis, and you can see here when it is square that dial stays on 0 when you run it across the face of the vise. Now I'm loading and unloading my tools for the operation and setting their lengths. Here you can see what the mill is going to be doing in the CAD program. It starts off by facing the material with a 1/4 inch end mill, and then it bores out the holes and cuts out the dimensions. And then goes in and cuts the bevel, and then it cleans up the bevel with an 1/8 inch ball end mill. Then it cuts a slot, does a quick chamfer around the edges, and engraves my logo. And now it's time to run the actual program. Here you can see the finished first operation of the first blade I ran, and you can also see where I ran the slotting operation wrong and it broke the 1/8 inch ball end mill and messed up that slot. So going into my CAD and CAM to check what I ended up messing up, I decided that I had messed up the cutting feed rate. I hadn't actually messed that up, and you'll see what I did mess up in a quick second. Now I'm running the program I had just finished reprogramming, and I was watching it so I could catch where I messed it up and slow the program down so I wouldn't break the end mill. You can see here that the program did actually run and work, but it ran less than optimally because instead of running my spindle at 10,000 RPM, I was running it at 1,000 RPM. So I had to slow the feed rate way down to not break the end mill again. So I went into my program to double check that, and surely enough, I forgot to add a 0, which is where most of my mistakes come from, just doing something stupid like that. And then my feed rate, I could put it back up to where I originally had it because it was the spindle speed and not the feed rate that was the issue. Here you can see the finished op 1 of the first blade. I went ahead and ran the slot on that, even though I'd ended up scrapping this blade just to make sure that was working properly. And you can see I fixed the position it was in as well as getting that in there. Here you can see what the rest of the blades are going to look like, and a comparison between the last batch of blades. You can see here that I removed the machined bevel lines, and that's the comparison. The particular blade it's being compared to was a scrapped blade that I accidentally surface ground one side too far. I then machined another blade, and you can see here what it looks like without that messed up slot. You can see it looks much better and cleaner, and I'm super happy with how these are turning out. So I'm gonna go ahead and run the rest of these op 1s. Now that all the op 1s have been ran, you can see them here. Everything turned out pretty well, and I only ended up having to scrap that one blade that I messed up in the very beginning. Now that all the op 1s are finished, it is time to do the op 2s. It's the same process as before, just on the other side, so go ahead and enjoy the time lapse. I know you just finished watching the whole blade get machined, and we're taking a small step backwards, but right after it finishes the first couple facing passes, I go ahead and check the blade thickness with a micrometer to make sure it's machining at the right thickness. Here you can see what the blades look like with op 1 and 2 done. This is the one that I messed up, so I didn't bother serializing it because there's no point wasting a number on the blade that's going to end up getting scrapped. Anyways, now that this is done, I'm going to go ahead and run the rest of them. I forgot to film all the op 2s when they were done, and I also forgot to film cutting them out of their casing, but you can go ahead and check that out in this video. So we're just skipping ahead to bagging all the blades for heat treat. Again, if you want more heat treat information, go ahead and check out this video. It's a pretty boring process, and there's no point wasting a bunch of time in this video going over exactly what I'm doing. Now all the baggies are around the blades so they don't oxidize while in heat treat, it's time to go ahead and heat them up. I go ahead and put the blades in 5 at a time in my Paragon heat treat oven. This is an electronic kiln that will very accurately hold the temperature at a certain point and can control how fast things heat up or cool off. These blades are held at 2025 degrees for about 15 minutes before I plate quench them. And now I plate quench the steel. Now that the blades have been hardened and tempered, it is time for them to be cut out of their little baggies. Here you can see how the blades look out of heat treat. They are very clean with some small little heat treat colors. Now that the blades have been heat treated, it is time to surface grind them to their final dimensions. I leave them a few thou over and then take them down the rest of the way on the surface grinder to make sure I can get everything extremely flat and precise. After they're surface ground, I then bead blast them. Bead blasting helps give them a even texture over where the surface grinding and machining was. It just combines the two very different textures and allows me to finish them evenly in future processes. Here you can see the difference between a unsurface ground and blasted one and a surface ground and blasted one. There's a big difference, and the blasted one has a super even texture. You can also see the difference in the blasted texture between the one with the mill lines and the one without. I don't like to leave them blasted, however, because I don't like how the finish feels, so I go ahead and Scotch-Brite that finish off, and it gives them a nice shiny smooth look without the difference in finish. Here you can see what it looks like after it's been Scotch-Brited. It adds almost a hand ground look to the blade. The next step is to buff the blades. I'm not going for a mirror finish or anything, and this step in this process is probably not needed, but I like to do it to get in all the little cracks and stuff the Scotch-Brite couldn't get in, to make everything a more even finish. After the blade's been cleaned, it is time to assemble them on the handles. So I go through basic assembly, and one handle is binding, and I'm not sure why, because it matches the correct dimensions. So I go ahead and grab a different handle and assemble that, and it swings freely without any issues. And so now I know it's a problem with the handles, and so I go ahead and change my Zen pin, and that fixes the problem right up. Here you can see what the mostly finished and assembled knife looks like. I'm super happy with how these new blades have turned out, and I really like them. Obviously, I haven't closed the final handle gap in this dimension, so we'll go ahead and do that in a second. I went ahead and stepped outside for some better lighting so you could see more of the finished product. I'm super happy with how these blades turned out in terms of finish, but there are some small changes I still want to make to the overall design and ease of manufacturing. If you want one of these knives, go ahead and follow me on Instagram. My link is in the description, and I'll announce when I have drops available. You can also check out my website because there is a chance you get lucky and I do have some up. If you made it this far and you enjoyed the video, please consider liking and subscribing. It helps out a lot. Thank you very much,